There were other questions as well. Pluto's orbit is different from the orbits of the planets. Think of an orbit as a lane on a racetrack. Just as runners have their own lanes on the track, each planet has its own orbit around the Sun. For the runners, all the lanes together make up the racetrack. For the planets, all their orbits taken together make up the orbital plane. Just as runners don't run outside their individual lanes, planets don't travel around the Sun outside their individual orbits. Except for Pluto. Pluto crosses Neptune's orbit. All of the planets, comets, and asteroids in the solar system are in orbit around the Sun. Their orbits line up with each other, creating an imaginary flat disk called the orbital plane. Pluto's orbit, which takes 248 Earth years to complete, brings it outside the orbital plane. For 20 years of each orbit, Pluto moves inside the orbit of Neptune, making Neptune farther from the Sun than Pluto. Pluto was inside Neptune's orbit from 1979 to 1999. Here on the next page, we have a photo of Pluto and its moon, Charon. Pluto was 2.6 billion miles from Earth when the Hubble Space Telescope took this photo. All right, so let's read along and see what Charon is. The shape of Pluto's orbit is different too. The larger planets travel around the Sun in an oval-shaped orbit. Pluto's orbit is more of a stretched-out oblong. The other planets' orbits are level with the Sun. Pluto's is tilted. Comets' orbits are often tilted. So astronomers wondered, could Pluto be a comet? And of course, there is Pluto's size. Astronomers knew Pluto was tiny when it was discovered in 1930, but because it was so far away, it was hard to see the planet clearly. Pluto appeared as a tiny dot of light in the night sky. Then telescopes improved. In 1976, American astronomer James Christie discovered that the tiny dot everyone thought was Pluto was really two objects. Pluto had a moon, Charon. Once astronomers discovered that Charon was separate from Pluto, they realized that Pluto was even smaller than they had originally thought. Pluto is only 1,440 miles in diameter, but Charon's diameter is 790 miles. They began to ask, is Pluto too small to be a planet? And since they had found Charon, they wondered, were there more objects out there the size of Pluto? Were they planets too? So Pluto was hard to see because it was so far away, and as a result of the telescopes improving, James Christie was able to discover that Pluto had a moon. But this led scientists to ask many questions. Was Pluto too small to be a planet? Were there more objects the size of Pluto? So this raised many questions that the scientists wanted to try to answer. Finding planets. In 1992, astronomers made an amazing discovery. 9.3 billion miles away from our Sun is another region of space, shaped like a disk. Astronomers believe it contains approximately 70,000 icy objects, including Pluto. This area of space was named the Kuiper Belt, after the Dutch-American astronomer Gerard Kuiper, who lived from 1905 to 1973. In 1951, more than 40 years before its discovery, Kuiper actually predicted that a region like this might exist. Michael Brown, Chad Trujillo, and David Rabinowitz are planetary astronomers who study Kuiper Belt objects, or KBOs. People often call these men the planet finders. Together, they hunt for planets at the outer edges of our solar system using the Samuel Oschin telescope at the Palomar Observatory in California. The Oschin telescope is a wide-field telescope, which means it views broad regions of the sky at once. When paired with a camera at the observatory, it can take pictures of these large areas. In the past, astronomers had to spend their evenings peering through telescopes in order to study the night sky. Now things have changed. Robots control the Oschin telescope and its camera. In the evenings, the cameras and the telescope at the Palomar Observatory are at work. They take 3 photographs over 3 hours of the part of the night sky the men want to study. Any object moving across the background of billions of stars and galaxies will be captured in pictures. The pictures are then sent from the telescope's cameras to a bank of 10 computers at the California Institute of Technology. Next, the computers decide which objects appear to be moving and therefore might be a planet. Usually, the computers select about 100 objects. When the men arrive at work each morning, the pictures are ready for them to view. So here we have a very clear image. It says objects in the Kuiper belt are so far away it takes them hundreds of Earth years to orbit the sun. So here we have more features of expository text. We have the subheading finding planets. We have a photograph. We have a caption. And all of these help us visualize the information that is presented, helps us visualize the Kuiper belt and understand how far away it is. Mike Brown says most of the objects he looks at on his computer screen are not planets. Many are caused by some kind of flaw in the telescope's camera. But every once in a while, an astronomer will get very lucky and something new and exciting will appear. That's how Mike and his team discovered 2003 UB313, or Xena, as it was nicknamed, on October 21st, 2003. Mike says, the very first time I saw Xena on my screen, I thought that there was something wrong. It was too big and too bright. Then I did a calculation of how big it was and how far away it was. Xena is the most distant object ever seen in orbit around the sun. Pluto is 3.6 billion miles away, but Xena is 10 billion miles away and is approximately 400 miles bigger in diameter than Pluto. It takes Xena more than twice as long as Pluto to orbit the sun. Xena was always a nickname. On September 13, 2006, the newly discovered celestial body officially became Eris, for the Greek goddess of strife and discord. It seems an appropriate name, since there was a lot of strife and discord surrounding Eris. Was it a planet or not? So Pluto is 3.6 billion miles away, but Xena is 10 billion miles away. Xena is 400 miles bigger in diameter than Pluto, and it takes it twice as long as Pluto to orbit the Earth. So this comparison helps us to understand why scientists asked whether or not Xena was a planet, because Xena was much bigger than Pluto, so they thought it might be a planet. What is a planet? Because scientists always check and recheck their work, Mike Brown and his team of astronomers didn't announce their discovery of Eris until January 5, 2005, after they had a chance to verify their information. When they revealed their discovery, many people thought the solar system had gained its 10th planet, but others disagreed. Soon an argument was raging among astronomers all over the world, and the argument came down to one question: what exactly is a planet? It seems surprising, but until August 24, 2006, science never had a definition for the word planet. Dictionaries had definitions, of course, but most said something similar to a large celestial body that circles around the sun or another star. For a scientist, that definition had problems. For one thing, what is meant by a large body? Jupiter, the largest planet in our solar system, is 88,700 miles in diameter, and it is a planet. Pluto is only 1,440 miles in diameter, and at the time, it was a planet too. The question, what is a planet, needed an answer, and the International Astronomical Union decided to create not one definition, but three. The IAU came up with three classes of objects that orbit the sun: planets, dwarf planets, and smaller solar system bodies. The IAU decided that a celestial body is a planet if 1. It orbits the sun. 2. It is round or nearly round because its gravity has pulled it into that shape. 3. It is big enough and has enough gravity to clear the neighborhood around its orbit. What does this mean, clear the neighborhood? The first two qualifications for planethood, orbiting the sun and a round shape, are easy to understand. The concept of clearing the neighborhood is a little bit more difficult. It might help to think of planets as the schoolyard bullies of the solar system. In order to clear the neighborhood, a planet has to be big enough and have enough gravity to get rid of any celestial objects in its way. A large planet might clear its orbit by using its gravity to pull other smaller objects toward it and destroy them, the way asteroids are destroyed when they hit Earth. So here, all of these are the qualifications that were given for a celestial body to be a planet. Or a planet might clear its orbit by attracting smaller objects toward it, then turning them into moons that remain in orbit around the planet. Sometimes a planet will simply push a smaller body into a completely different orbit and will get rid of it that way. But no matter how it does the clearing, according to the IAU definition, a planet must travel in its orbit by itself. The secondary category of planets, called dwarf planets, have the following characteristics. They must: 1. Orbit the Sun, 2. Be round, 3. Not be a moon or a satellite of another planet. By this definition, Pluto is a dwarf planet. And although Charon, its former moon, is still locked in an orbit with Pluto, it is a dwarf planet too. Now they are known as a double planet system. Ceres is a dwarf planet too. And Mike Brown's discovery, Eris, is one as well. They are dwarf planets because they orbit the Sun, they are round, and they are not moons of another planet. But they're too small to have enough gravity to clear their neighborhood. Pluto, Charon, Ceres, and Eris are all KBOs, orbiting far out in space with other objects in the Kuiper belt. Everything else, asteroids, comets, meteors, are now members of the third class of objects that orbit the Sun and are called small solar system bodies. Some astronomers think the definition of a planet will change again in the future. Others think the current definition is a good one and will last. Science is exciting because it continually changes as new information is discovered. A long time ago, we thought there were 6 planets. Then we thought there were 8. For a while, there were 9. Then it was back to 8. Then with Pluto, the number jumped up to 9 again, and now it's back to 8, and that is just in our solar system. So by italicizing the word our here, the author of this expository text is implying that other solar systems in space may also have planets that just haven't been discovered yet. We know our Sun is not the only star that has planets in orbit around it. New planets are forming around other stars, making new solar systems. There are 200 billion stars in the Milky Way galaxy alone, and there are billions of galaxies full of stars in the universe. As we study those planets and the stars they orbit, we ask questions. Are there other planets like Earth somewhere in the universe? Does life exist on them? We ask questions as we study the planets in our own solar system too. Does life exist on one of them? Or even one of their moons? Did life ever exist on any of them? Is Earth the only planet with life? Are we alone in the universe? In January 2006, NASA launched the New Horizons mission to Pluto. If all goes well, the New Horizons spacecraft will reach Pluto and Charon sometime in the summer of 2005. So this expository text was written quite a long time ago. Then instruments aboard the spaceship will begin to get a close look at these distant worlds. As the information beams back to Earth, scientists here will study it, trying to learn more about the origins of our solar system and what lies at its outer edges. Pluto still has a story to tell. There are questions that need answers, and the answers will come through science. New information is just waiting to be discovered. So scientists are constantly discovering new information that refutes old conclusions or causes them to revise the conclusions that they have made. And an example of this is the evidence that showed that Pluto could no longer be considered a planet. So look at the question on the bottom of the page. Why do some astronomers think the definition of a planet will change in the future? Because we are still learning new information about the solar systems, and as we learn new information about space, definitions may continue to change.